You have chosen answer B. We first check the boundary conditions of no slip at the surfaces and interface between the fluids. We notice that the fluid is moving at the top surface, so that matches up with that boundary condition, and it is not moving at the bottom because it's stationary, so it also matches there. Now this is true for all 5 figures. It must be true at the interface between the two fluids that they have the same velocity, so that checks. This ruled out figure C. Now the relative viscosities will dictate how the velocity profile changes. Now given a constant shear stress that's being applied to the fluid based on that top plate moving, a more viscous fluid will experience a lower shearing rate. That is, the velocity gradient will be less for a more viscous fluid. Now we could think back to Newton's law of viscosity, which related the shear stress to a viscosity and a rate of shearing strain. Now this rate of shearing strain is also written as dV dy if we say y is the distance between the plates. It is important to note that we do not look at these profiles and slopes as we would on a typical XY Cartesian plot. So as you look at these two, you would say, well, this slope is less steep than this slope, so this velocity gradient must be greater. That's not true. If we look at the difference in velocities at 2 points, let's pick the velocity here and here, we notice that those velocities aren't as different as, say, the velocity here and down here. So the velocity gradient up here is actually less than the velocity gradient at the bottom, assuming that the thickness of the two fluids is the same. So this means an infinite slope would be closer to 0 degrees, whereas the vertical line indicates a slope of 0, or no change in the velocity. Thus, this figure is correct. Now, the relevant slopes of the velocity gradients should be proportional. Thus, we would expect the slope of this fluid down here to be about 5 times the slope of this fluid up here. Now, another point to make is in asking how the shear stress changes as a function of height. Now, if you answer that it doesn't, you may be correct. Check out the other screencasts on these topics to strengthen your understanding of this important relationship that we use in fluids.